Hello sir, this is the second video of the IEEE 33 GWO. As mentioned before, from the main program, the GWO function called from there, and after that, depending on the number of position, maximum iteration, cost function, and number of variables, and started with the initial some parameters related to the GWO, like alpha score and beta score, alpha position, beta score, beta position, delta score, delta position, and also the position vector, and the best score and best position, and global best score and global best position. And then we initialize or initial the convergence factor vectors by 0. And after that, we started the initialization process, as you see here, from here. In the initialization process, now it is to determine for each particles or position randomly in each particle which the line it is open. So in each particle we have five line should be open it to reconfigure the IEEE 33 passes. So, and after that we entered in the loop, as you see here, to check if in each particles or each position have 5 open line. And after we finished from checking, now we go to the main program and started to the main program to calculate the cost of each particle, as you see here. Now we sorted the position, as you see here, and then this process to determine which the position which the line it is open it, depending on the position. And then after we determine which the line it is open, now we apply the cost function to calculate the fitness value from the object function that we explained in the previous video. And after we calculated the fitness value, now in the first indication put it the fitness in the best cost, and calculated the fitness to the best score, and calculated the fitness with the global best score. If it is less than the best score or the global best score, now the fitness it is stored in the best score variable, and the position in the best position value, and the same thing for the global best score. And after we finished from that, now we started with the alpha, beta, and delta of the GWO. The alpha, it is mean that in the GWO it is the best position that gets the best fitness value, or the lowest fitness value, the lowest one. The beta, it is the second best one. That means which the position has the second best fitness value after alpha score, and the delta, it is the third best value that the position get it from the particles. And after we finished our updated the alpha, beta, and delta, now we go to the calculate the GWO parameters. The first parameter, it is the delta alpha. Delta alpha, that means the subtract between the alpha position and the current position of the particles. So after that we calculated the x1 variables depending on the delta alpha and also the alpha position. Then we go to the calculated delta beta. It is the difference between the beta position and the current position, and then we calculated x2 depending on the beta position and the delta beta. And the last one, it is to calculate the delta position and the subtract or the difference between the delta position and the current position, and then calculated x3 depending on the delta position and the delta. And after we finished to calculate the x1 and x2 and x3, now we need to calculate the new position of the particle depending on the x1. x2 and x3 divided with the 3 to calculate the new position of the particles. And after that, now we sorted that, and we determined which the line it is open depending on the this equation. And this process now that mean we sorted the position depending on the value. The first 5 of the position that get it the more valuable, more values, put it as the open one. That mean open this line. So in this position we have all the choice of line, but then we sorted depending on the value of this each line, and after that we get, or we put the first 5 variables as an open one, and put it 1 for this location, or for this the line. And after we determine which the line will be open it, then we apply the cost function to calculate the fitness GWO, and compared with the current fitness to get which the position and the fitness it is the best. And then we will repeat the process as you see here. After we store the global best score in the conversion factor and display the iteration with the best cost, as you see here, now we repeated the process for the maximum iterations. So we will go quickly explain. As you see here now, from the main program, now we get it the position, the new position, sorted that, and then after that we determine which the position it is, or the line it is open or not. And after that we apply the cost function, compare the fitness that we get it from the cost function with the p best and the global best, and then we update alpha, beta, delta dependent on the value of the best cost that get it from the cost function. And after we updated that, now we calculated x1, x2, x3 dependent on the beta and alpha, beta, and delta position and the current position. And after that we calculated x1, x2, x3 to calculate the new position of the particles. And then we arrange that which the line has the bigger values than other. And after we sorted that, now we choose the first 5 line to be open it, and then we applied the cost function to calculate the fitness GWO and compare with the current GWO fitness value, and store it in the position and the fitness value. And after that we store the G-best score and the conversion and printed the conversion factors, convergence values or curves in the command window, and this repeated the process for the maximum iteration. And then we finished the program. As you see here, this is after run that. In each, as you see, in each iteration we printed the best cost with the values, and after that we printed the result. The result, that means the switches, which switch it is open. As you see here in our process, the line 10 and line 12 and line 15 and line 21 and line 35 it is open, and the power loss dependent on this reconfiguration. That power loss will be like this, and the reactive power like this, and also voltage division like this, and voltage stability index it is this, and the total system cost it is 3789. And if you see the figures, as you see here, this is the convergence curve, how the best value behave with during the iteration. As you see here, in this point, after 3 iteration, we get it the best value. and also as you see here, the voltage profile, how the voltage behave for each bus, and also how the system, the PV generation, and how the grid behave, and how the distributed generation behave with the new reconfiguration. And the last one, it is how the EV load and the losses behave with the new reconfiguration. That is all of our explanation of the code of IEEE 33 bus GWO. We hope it is clear. If you have any question, you can ask us, and we will help you and answer you about your question. Thank you very much. See you later.